Hello, this is the first video for Algebra C. It's going to contain the page 1 notes, questions 1 through 11. You'll have to access the other videos if you want further help. So question 1, you're asked to change this radical form into exponent form. Now to change from a radical to an exponent, you're going to end up with a fraction exponent. So what you're going to do is you're going to take what's in the inside here, you're going to write that. That exponent that's currently with it, that's going to end up being the numerator of the fraction, or the top number. Now the denominator is going to come from what kind of root it is. So normally when we work with roots, we're going to see that it'll have a small number here. There isn't one on question 1, but you see it over here on question 2. If there's ever not a number there, it's assumed to be a 2. This is called the square root. It's the only root that doesn't require you to write a number. So as we're switching to exponent form, we know that if there's not a number on that root, it has to be a 2. So this would be the exponent form of question 1. Question 2, we're going to do the same thing. Take what's on the inside here. And our denominator is going to be whatever root it is. And we see here that it's the 5th root. And that is the rational exponent form of question 2. For question 3, I want you to pay attention to the fact that I had a typo in the review. It only said 3x to the 8th to the power of 3, and it should have been to the power of 1/3. So for question 3, we're going to do the opposite of what we did for questions 1 and 2. For questions 1 and 2, we took the radical form and switched it to exponent form. This is already in the exponent form, and we're going to switch it to radical form. So we're going to take everything on the inside here. That's going to be what's in the inside of your radical. And then our number of what root it is going to be the denominator. So it's going to be the cubed root, or the 3rd root. Now, this is in radical form, but it's not quite simplified. In order to simplify, I'm going to have us expand everything in the inside. 1, 2, 3, 4, 5, 6, 7, 8 x's. Now, a cubed root means if we have 3 of something, then we can pull that out. So, I'm looking and I see 3 x's here, so one can come out, the other ones will disappear. I see 3 x's here, again I'll be able to bring one out, the other 2 we can forget about. And then I only have 2 left over here, so that means we're not going to be able to bring any out from there. So I'm going to have x times x on the outside, the cubed root of 3 x times x on the inside. One step further to simplify, x times x is x squared, so we're going to rewrite it in that form. And this is your final answer. This question is almost exactly the same, except it has to the power of 7. So again, we're going to take this and put it in our cubed root because of the 3 here. 3x to the 7th. I'm going to go ahead and expand that 7 out. 1, 2, 3, 4, 5, 6, 7. Again, since it's the cubed root, we have to look for pairs of 3 to pull out. So here we have 3, so you're going to be able to pull 1x out. Here we have 3, so you can pull 1 out. And that's going to leave 1 left on the inside. I'm going to go ahead and write those 2 x's that we pulled out as x squared times the cubed root of 3, and we have 1 x left on the inside. So this is your final answer. Next we have the product rule. So in this case, we are multiplying these 2 parts of this expression. So go ahead and multiply your coefficients. Coefficients means the numbers out front. 20 times 2 is 40. Now the product rule for exponents say if the base is the same, like this x is the same as this x, then you add the exponents. So I'm going to add my exponents for my x. So I'm going to have x to the power of 2 plus 5. And I see that I have y's here. They have the same base, so I'm going to go ahead and add their exponents, which will give me the final answer of 40. X to the 2 plus 5 is 7. Y to the power of 3 plus negative 2 is just 1. We don't usually write 1 as an exponent. You can, but it kind of looks weird, so I'm just going to leave it. If there's not an exponent showing, everything's assumed to have an exponent of 1. Next, we're going to work with the quotient rule. First thing I'm going to address is these coefficients. This is just the fraction 6 over 8. We can simplify that fraction by dividing both of them by 2. So I'm going to have 3 over 4. Next, I'm going to address the actual quotient rule, which says if I have the same base, which I do right here with the y's, you're going to subtract the exponents. So that's going to be y 20 minus 14. You're going to leave the y wherever the greater y was. So the 20 is a lot larger than 14, so it's going to remain on top. So your answer is going to be 3y to the 6 over 4. Next, we have the power rule. The power rule states that if you have a power raised to a power, you're going to multiply the exponents. Now, it's important to note that if you don't see an exponent, that means technically it has an exponent of 1. So this coefficient of 8 technically has an exponent of 1. So we're going to distribute this power of 3 to everything. So we're going to be multiplying it all. So I'm going to have 8 to the power of 3, x to the power of 3 times 3, and y to the power of 4 times 3. 8 times 8 is 64. 64 times 8 is 512. X to the power of 3 times 3 is 9. And y to the power of 4 times 3 is 12. That would be your final answer. Question 8 addresses the negative exponent. We are not allowed to leave anything with a negative exponent unless we're working with scientific notation. So we have to get rid of that negative exponent. In order to do that, it's important to understand what a negative exponent means. Now, exponents in general, when they're positive, mean repeated multiplication. So if we're going to do the negative of that, negative means the same thing as opposite. So a negative exponent is really saying we have repeated division. So in order to represent that, we're going to make this into a fraction and move anything that has a negative exponent to the denominator. That will allow us to switch it to a positive exponent. Anything that does not have a negative exponent stays in the numerator. So my answer would be 10 y to the 5th, x to the power of 3. This is the same rule as a couple questions back. This is the power rule. Remember that anything that does not currently have an exponent technically has an exponent of 1. And we're going to distribute that exponent to every piece. So really we have 3 to the power of 1 times 4, x to the power of 4 times 4, and y to the power of 2 times 4. To simplify that, 3 to 1 times 4 is to the 4th power, x will be to the 16th power, y to the 8th. And then we can actually figure out what 3 to the 4th power is. 3 times 3 is 9. 9 times 3 is 27. And then 27 times 3 will be 81. And we still have x to the 16th, y to the 8th is your answer. Question 10. This is one of my favorite rules because it is so simple. Anything to the power of 0 is 1, with the exception of 0 to the power of 0, which is undefined. Everything else to the power of 0 will always be 1. You don't even have to think about it. You just say, hey, That's the power of 0. The answer will be 1. Even if it's a really long, complicated problem that looks terrifying, if anything is then written to the power of 0, the whole answer becomes 1. So it's pretty simple. Power 0, your answer is 1. Question 11 asks us to write a function for the given table. So we need to figure out what is the pattern. How are we getting from 4 to 12, and 12 to 36, and 36 to 108? And what you'll figure out is each time we are multiplying by 3. Well, a typical exponential function looks like y equals a times b to the power of x. B is going to be whatever that multiplication factor was. So we're going to have 3 to the power of x. A is generally going to be your first term. So in this case, it's going to be 4. Now, generally speaking, we start off with 0. And this is 1. So in order to get us to a starting point of 0, we need to place a minus 1. You should always double check that the function you came up with is correct by plugging in some of those x values to see if you get the appropriate y value. If I plug in 1 for x, I'm going to have 1 minus 1. 1 minus 1 is 0. Anything to the power of 0 is 1. So then I end up with 4 times 1, which is 4. That checks out for plugging in the value of 1. Then we're going to do one more check. This time I'm going to plug in 2. So 2 minus 1 is equal to 4 times 3 to the power of 1, which is just 3. And your answer would equal 12. That checks out as well, because when we plug in 2, we should get 12. So that means this is the correct function. That's all for this set of notes. Continue on to the Algebra C page 2 notes for further help.